To reach another galaxy, a spacecraft must travel millions of light years across a void so vast that conventional physics almost loses its meaning. While our current rockets are barely capable of leaving our own solar system, scientists and mathematicians have already drafted the blueprints for vessels that could potentially bridge the gap between islands of stars. These designs represent the absolute limit of human imagination and the laws of the universe, ranging from massive city-sized habitats to engines that warp the fabric of reality itself. The generation ship. This concept relies on the idea of a self-sustaining ecosystem built within a massive, rotating hull to simulate gravity. Instead of trying to break speed records, these vessels are designed to be mobile planets, where hundreds or thousands of people live, reproduce, and die over centuries or even millennia. The engineering focuses on closed-loop life support systems and extreme structural durability to survive the long trek between galaxies. It represents a philosophical shift in travel, where the journey itself becomes the permanent home for the crew's descendants. Nuclear pulse propulsion. This design, famously studied during Project Orion in the mid-20th century, moves a ship by ejecting and detonating small atomic charges behind a massive steel pusher plate. Each explosion provides a powerful shove, propelling a heavy craft to a significant fraction of light speed without the need for complex, fragile engines. While the technical physics are sound and surprisingly simple, the model remains sidelined due to the environmental risks of nuclear fallout and international treaties banning atomic tests in space. It stands as one of the few high-speed models that could arguably be built with technology not far beyond our current reach. The laser sail. This model removes the weight of fuel entirely by using a paper-thin, reflective sail pushed by high-powered laser beams fired from a home base, such as a lunar station or an orbital array. Because the ship doesn't have to carry its own energy source, it can be incredibly light and reach speeds that would be impossible for traditional rockets. Current initiatives like Breakthrough Starshot are exploring this on a microscopic scale, aiming to send tiny probes to neighboring stars. Scaling this for intergalactic distances would require lasers of unfathomable power. Yet the fundamental physics remain a leading candidate for high-speed transit. Fusion rockets. Using the same process that powers the sun, these ships would harness the energy of fusing light atoms like hydrogen to create a constant, high-efficiency exhaust. Concepts like Project Daedalus envisioned a two-stage craft that could reach over 10% of the speed of light, making it a favorite for theorizing about deep space travel. The main hurdle is that we have yet to achieve a stable, net-positive fusion reaction even on Earth, let alone inside a compact engine. Once mastered, fusion could bridge the gap between slow chemical rockets and the high-energy demands of leaving a galaxy. Antimatter engines. This is the most efficient form of fuel-based propulsion possible under the known laws of physics because matter and antimatter annihilate each other to release 100% of their stored energy. A ship utilizing this power source could theoretically reach near-light speeds, making the vast distances between galaxies slightly more manageable through the effects of time dilation. The primary challenge is that antimatter is the most expensive substance in the universe to produce and incredibly difficult to store safely. It remains a gold standard for theoretical propulsion, representing the peak of what mass-to-energy conversion can achieve. Warp Drive. This mathematical model suggests a way to circumvent the cosmic speed limit not by moving faster than light, but by manipulating the fabric of space-time itself. The ship would sit inside a bubble where space is contracted in front of it and expanded behind it, effectively sliding the vessel across the universe. While it appeared in scientific literature in the 1990s as a serious proposal, it requires a theoretical form of negative energy that we haven't discovered yet. If it ever moves from math to reality, it would transform intergalactic travel from a million-year trek into a journey of weeks or months. The black hole drive. This highly advanced concept involves creating a microscopic, artificial black hole and capturing its Hawking radiation to power a ship. A small enough black hole would radiate an immense amount of energy, providing a constant and incredibly powerful source of thrust for a very long period. Managing such a volatile object would require a level of gravity control far beyond our current capabilities. It serves as a reminder of how far our theoretical models can go, pushing the boundaries of what might be possible for a civilization millions of years more advanced than our own.